Hello friends, and welcome to another lecture on chemical engineering thermodynamics. Today we look into a problem which has come in Mumbai University Chemical Engineering Thermodynamics 1 paper. It has come twice, once in May 18 and the second time in May 19. Well, the problem is on your screen. Calculate the compressibility factor and molar volume for methanol vapor at 500 Kelvin and 10 bar by using pressure explicit form on volume explicit form of virial equation of state. Now the data is given for B and C. Now from the data of B and C, it is amply clear that this is the constant given for the virial equation of state or virial equation of state in the volume explicit form. So let's have a look at that equation first. So what we are going to do is we are going to write it down. So the equation is Z is equal to PV by RT is equal to 1 plus B by V plus C by V square. Now it's amply clear that the constants are given for the volume explicit form, right? Now we have to write the constants in the proper units, because if we take the unit of R as kilojoule per kmol Kelvin, so we will have to convert this also into meter cube per kilomole. So if you convert this into meter cube per kilomole, this will be minus 2.19 into 10 raised to minus 1. That's minus 0.219. And C similarly is going to be minus 1.73 into 10 raised to minus 2. That's going to be minus 0.0173, right? Now what we do is we write the equation, okay, and we multiply this entire equation with V square. So what we get is PV cube is equal to V square plus B plus C. So that's going to be PV plus C. So we finally get this equation as PV cube by RT minus V square minus BV minus C is equal to 0. And we enter the values now. Now we have the pressure at 10 bar and temperature at 500 Kelvin. So 10 bar is going to be 10 into 100 kilopascals V cube over 8.314 into 500 is not is equal to, then we are going to have minus V square plus 0.219, I guess that's the value, right? V plus 0.0173. This is going to be equal to 0. Now we will get the volume from this equation. So let's take our calculator and solve it out. So we go to mode and we go to 5 and we go to 4. So first we will calculate the value of the constant for V cube. So that's going to be 1000 divided by 8.314 into 500. That's it. So minus 1 is going to be the constant for V square. That's it. So 0.219 is going to be the constant for V. And finally, we are going to have 0.0173. That's it. And now we have the volume. That's 3.92. So the volume we have now is 3.92 meter cube per K mole. And we also have to calculate the value of Z. So this is going to be equal to 8.314 into 500 divided by 10 into 1000 into 0, not 0, that's 3.92. So we have this as 8.314 into 500 divided by 1000 multiplied by 3.92, and the value of Z is 1.060. So the value of Z now we get is 1.060. So there we have the value of Z, 1.060. Right. Now the virial equation written in terms of pressure is as follows. Z is equal to 1 plus B dash P plus C dash P square. Now here we have B dash is equal to B by RT and C dash as is equal to RT square C minus B square. So that's the equation. That's the equation you have. I have written it down. So we calculate the value of B dash. The value of B dash, it's very simple, 0.219 minus, so that's 0.219 divided by 8.314 into 500. Now that's going to be equal to minus 0.219 divided by 8.314 into 500. So that's equal to minus 5.2682 into 10 raised to minus 5. So that's minus 5.2682 into 10 raised to minus 5. And now we should calculate the value of C dash. So C dash is going to be nothing but C, which is given as minus 0.0149. So let's check it once again. 173. 0.0173. Yes. Minus 0.219 the whole square. So let's check it once again. 219 the whole square, yes, over 8.314 into 500 the whole square. So we have C dash as minus 0.0173 minus 0.219 the whole square divided by 8.314 into 500, and that will be equal to minus 3.7765 into 10 raised to minus 9, minus 3.7765 into 10 raised to minus 9. So the first thing that we can do is we can calculate the value of Z. Here we can calculate the value of Z first. So Z is going to be equal to 1 plus B dash, which is going to be 5.2682 into 10 raised to minus 5, and consistently we have maintained the value of R as 8.314 kilojoule per kmol Kelvin. So we take the value of pressure in bars. So that's going to be, sorry, not in bars, in kilopascal, that's going to be P. Okay. So we have a minus sign here because B is minus. So this is a minus. And the value of C is also a minus. So we are going to write it as 0. That's the value of C. 3.7765 into 10 raised to minus 9 into 1000 the whole square. Right? So let's check what is the value of Z we get now. So that's going to be 1 minus 5.2682 minus 5 into 1000 minus 3.7765 minus 9 into 1000 the whole square. And we get the value of Z as 0.9435. So we get the value of Z as 0.9435. And let's calculate the value of volume. So the volume is going to be nothing but 8.314 into 500 into the value of Z, that is 0.9435 divided by 1000. So the volume we are going to get is going to be equal to 0.9435 into 8.314 into 500 divided by 1000. Okay, so that's 3.9221. So that's 3.9221 meter cube per K mole. Right? So we see that we have a slight difference in the value of Z, and therefore we have a difference in value of V. So that was all about calculating the volume and the compressibility factor using the virial equation of state. Now we need to understand that this is an equation of state which was used for modeling the gases, and it was based on the idea of compressibility factor. So fine, that will be all, guys. Do subscribe my channel for more such interesting videos, and have a great day. Bye.